Today we're going to be talking about the ratio test. And this is the most popular test on the AP. We use it for multiple things when we talk about infinite series. So the ratio test, as I just said, most tested on the AP. And what you do with the function that you have the series of is you take the a sub n plus 1 term divided by a sub n, and you find the limit as that goes to infinity. And your series converges if your limit is less than 1. Diverges if the series is greater than 1, and the test is inconclusive if it equals 1. Okay, so this first example. Again, what you want to find is you want to find the limit as n goes to infinity of the n plus 1 term. So everywhere you see an n, you plug in n plus 1. And it's the absolute value of that. So I multiply then by the reciprocal of the bottom, so the reciprocal of this, which is 3n plus 1 all over 2 to the n. Now it's just a lot of algebra. This first term is like saying 2 to the n times by 2 times by the big quantity of 3n plus 1. On the bottom we have a 2 to the n times by a 3 times by, I'm going to put this in parentheses, a quantity 3 times by 3 to the n plus 1. Now notice a few things can cancel. 2 to the n's can cancel. As we go to infinity, we don't really have to worry about a plus 1. So what I really have here is I have the limit as n goes to infinity of 2 times 3 to the n all over 3 over 3 to the n. What does that go to? That goes to 2/3, which is less than 1. So therefore, our series converges by the ratio test. Okay, another example. The ratio test is also really helpful if you have factorials. So let's do a factorial example. Okay, n plus 1 factorial is like saying n plus 1 times by one number less than that, which is n factorial, times by 3 to the n. On the bottom we have 3 to the n times by 3 times by n factorial. So now looking at this, n factorials cancel. 3 to the n's cancel. So we get the limit as n goes to infinity of n plus 1 all over 3. As n goes to infinity, this goes to infinity, which is greater than 1. So this series diverges by the ratio test. Okay, again, no, another one. So again, I take the limit as n goes to infinity of 3 to the n plus 2 all over 4 to the n plus 1 times by quantity n plus 1 squared. Now, I take the reciprocal of the bottom, Okay, so let's look at these. Let's simplify a few terms. Let's simplify the 4 to the n plus 1s over 4 to the n. That's going to simplify with a 4 in the denominator. The n plus 1 squared is still there. I don't know how long my line should be. Maybe it should be a little bit longer. 3n plus 2 divided, oh, I have an n squared on top. 3n squared over 3 to the n, or sorry, 3n plus 2 over 3 to the n plus 1. If I subtract those exponents, really all I am left with is a 3 in the numerator. Actually, I didn't need to give myself as much room as I did. So what does this limit go to? This limit goes to 3/4, which is less than 1. So this also converges by the ratio test. Okay, last example I want to do with you guys. So, use our ratio test. So, limit as n goes to infinity of -1 to the n plus 1 over the square root of n plus 1 all over n plus 1 minus 1, which is n, times by n minus 1 all over -1 to the n square root of n. Okay, so I have here basically a -1, but we're eventually going to be taking the absolute value of it, so that's really not going to matter, times quantity n minus 1 times by the quantity n plus 1 under a radical all over n times the square root of n. Well, the -1 isn't going to matter because I'm taking the absolute value, so I can kind of almost scratch that out and ignore that. Now, this would really be like n to the 3/2 over n to the 3/2, which equals 1. So remember back here, if our limit equaled 1, we're inconclusive. So this test would be inconclusive for a ratio test. But what test could I use? If you look at this is alternating. So what if I use my alternating series test? Now for the alternating series test, I want you to show me a few terms to show that the terms are decreasing. And then we look at the limit as n goes to infinity of square root of n over n minus 1. As I go to infinity of this thing, as I go to infinity, the bottom is going to get bigger faster than the top, so this is going to 0. And remember that if you go to 0, this converges by the alternating series test. And that is all for today. And I think this is the 4th time I've tried to record this video today. So there you have it.